Hi students, I am Tanvir Malik. Today we will start unit number 12 and this unit is about sound. In this unit, we will discuss how sound is produced, how sound travels, how sound can travel through solid, liquid, gases, how we can distinguish between different sounds. All these topics will be discussed in this unit. Which topics we will discuss in this unit? We will discuss making sounds. We will discuss how does sound travel, speed of sound, seeing and hearing sound. These topics will be discussed in this unit. How sound is produced? Sound is produced when a body vibrates. Whenever any surface vibrates, then sound is produced. Sound is produced by a vibrating body. It travels in the medium from one place to another in the form of compressional wave. There are two types of waves which we have discussed in previous chapter. That's longitudinal waves and transverse wave. Longitudinal waves are also called compressional waves. In compressional waves, particle of medium vibrate in the form of compression and rarefaction. Disturbance which is created in the medium, that will travel from one place to another in the form of compression where particles are close with each other, and rarefaction where particles are open. So sound waves are compressional waves. That means when sound wave will travel from one place to another, particle of medium, particle of air, solid, liquid, gas from which it is traveling, these particles will compressed or they will be opened. So in the form of compressional waves, sound wave will travel from one place to another. Musical instruments. These are the musical instruments. And these musical instruments, when play, then sound waves are produced in the form of compressional waves. And these waves will travel from musical instrument to our ears. Tuning fork. These are the tuning forks which are used in schools, in laboratories for production of sound. Tuning fork consists of two prongs and one stem. When this prong is hit with a rubber pad, then it starts vibrating. When it is vibrating, then compressional wave is produced, and this compressional wave will travel from the tuning fork to your ear. And you are able to hear the sound of the tuning fork due to its vibration of prongs. Production of sound. In school laboratories, we use a device called tuning fork to produce sound. Sound requires medium for its propagation. Without medium, sound wave cannot travel from one place to another. At the surface of the sun, atomic explosion are occurring. Nuclear fusion is occurring. But we will not hear that sound. Since in sun and earth there is space, and sound waves require medium for its propagation. Without medium, solid, liquid or gas, sound wave cannot travel from one place to another. For this purpose, we will perform experiment. We take a glass jar, we hang a electric bell inside this jar. And this bell is connected to switch. When we close the switch, we will hear the sound which is produced from the electric bell. But with the help of vacuum pump, if we start reducing the air inside this jar, then sound wave will be faint. At the end, we will see that hammer of the electric bell is striking, but we are unable to hear that sound since there is no air in the jar. From this experiment, we conclude that sound waves require medium for its propagation. When the air was in the jar, we are able to hear the sound. But when we suck the air with the help of vacuum pump, we are unable to hear that sound. So nature of sound wave is longitudinal. Longitudinal is mechanical wave which require medium for its propagation. Mechanical waves. What are mechanical waves? Such type of waves which require medium for their propagation. Without medium, sound waves cannot travel from one place to another place. This is the compression loudspeaker. Its surface is vibrating. When surface are vibrating, then compressions where particle of air close with each other, these are called compression. Where particle of air are far apart, this one, this portion, this is called rarefaction. So surface of loudspeaker is vibrating. Compression, rarefaction, compression, rarefaction. When it is moving from right to left, then compression is produced. When it moves in backward direction, then rarefaction, less pressure is produced. So at some points, air is compressed, particles are close with each other. At some points, particles become far apart from one another. So this disturbance travel from one place to another. This disturbance start from the surface of the loudspeaker, and this disturbance reach your ear. When it reach your ear, then sensation of sound is produced. So sound wave always travel in form of compression and rarefaction. Rarefaction means where pressure is less. Compression means where pressure is more, where particles are close with each other, and where particles are far apart. This is called rarefaction. Sound wave, nature of sound wave is compressional wave. So these are called compressional waves. This is the compressional wave. Particles are close and particles are far apart. Wavelength. Distance between two consecutive compression. This is the first compression. This is the next compression. This distance is called wavelength. This is first, this is second compression. This is called wavelength. This is called wavelength. Or distance between two consecutive rarefaction. This is the rarefaction. Less pressure. This is the less pressure. So distance between them is called wavelength of wave. If sound wave is a compressional wave, then it has wavelength. So wavelength is the distance between two consecutive compression or two consecutive rarefaction, or distance between one compression and one rarefaction. This is also wavelength. Characteristics of sound. Sounds of different objects can distinguish on the basis of different characteristics. And these characteristics are loudness, pitch, quality, and intensity. Now we'll discuss these characteristics one by one. First is loudness. Loudness, what is the loudness? Loudness is that characteristics by which we can distinguish between loud and faint sound. Without seeing any person, I am sitting here, I can recognize which sound is loud and which sound is faint. That is called loudness. So loudness is that characteristics by which we can distinguish between loud and faint sound. For example, when we talk each other, our voice is low, but when we address a public gathering, our voice is loud. This is the loudness. Loud sound produced by the horn, and faint sound when you are whispering with one another. If we don't see, but we can hear the horn and someone who is whispering without seeing, we can say that which sound is loud and which sound is faint. So it is that characteristics by which we can easily distinguish between two sounds. One is loud and second is faint sound. Effect on amplitude. Loudness depends upon amplitude. If amplitude of wave is large, then loudness is large. If amplitude is low, then loudness is low. This one. In first picture, amplitude is low. And in second, amplitude of wave is high. So loudness will be high. So loudness depend upon amplitude. It is directly proportional with amplitude. If we increase the amplitude of sound, then sound will be low. If we reduce the amplitude, then sound will be low. Next is effect on amplitude in waveform. This is the waveform of amplitude. First sound is loud sound and second is faint. Factors on which loudness depend. Loudness depend upon number of factors. Number one, amplitude of vibrating body. Number two, area of vibrating body. Number three, distance from vibrating body. So we'll discuss one by one. Amplitude of vibrating body, we have discussed. If the amplitude of wave is large, then loudness will be large. Loudness of sound varies directly with the amplitude of vibrating body. For example, sound produced by star will be loud if we pluck its wire more violently. Example 2, when we beat a drum forcefully, its sound will be loud. Reason is amplitude of surface is increased. Second is area of vibrating body. If a body has large area, then sound will be large. If an area is less and you are applying the same force, then sound will be low. For example, when you beat a drum, sound is loud. But when hammer of electric bell strike, sound is low. Electric bell sound we can hear only in the room, only in the house. But when a drum is beaten, its sound goes at large distance. So if the area of vibrating body is large, then sound will be large. If the area of vibrating body is less, then sound will be less. Loudness of sound also depend upon the area of vibrating body. Loudness increases if the vibrating body has larger area. If the vibrating body has small area, then loudness decreases. Example, loudness sound produced by large drum is louder than produced by small one because of large vibrating area. Distance from the vibrating body. Loudness also depend upon the distance. If the distance is large, then loudness will be very, very small. Since too much far a person is listening the sound, a person who is beating the drum. But if a person who is standing near the drum, he will hear the loud sound. So loudness is inversely proportional to the distance. Loudness of sound also depend upon the distance of vibrating body from the listener. It is caused by the decrease in amplitude due to increase in distance. Physical condition of ear. If a person is deaf, you are beating the drum forcefully, he will say no loudness since his ear is not working. So loudness also depend upon the physical condition of the ear. Loudness also depend upon physical condition of ear of the listener. A sound appears louder to a person with a sensitive ear than to a person with a defective ear. Pitch, second factor. Pitch is that characteristics by which we can distinguish between two sounds. One is grave, one is shrill, although loudness is same. In a room, suppose one children is talking, one elder is talking. Without seeing them, you can recognize their sounds. Which sound is of child and which sound of elder person. Although their loudness is same. You are standing at equal distance in a room. If some ladies are talking and some gents are talking, you can recognize their sound at the same distance. Their loudness is same, but their pitch is different. Sound of ladies and children is shrill and men is grave. So pitch is that characteristics of sound by which we can distinguish between a shrill and grave sound. That is called pitch. Factors upon which pitch depends. Pitch depends upon the frequency. Higher the frequency, higher will be pitch. Lower the frequency, lower will be pitch. Frequency means number of waves passing through a certain area. That is called pitch. Waveform of low and high pitch. This is the waveform of low pitch and this is the waveform of high pitch. First is this is low pitch and this is high pitch. Here frequency is high, here frequency is low. Voice of ladies is shrill. The voice of ladies and children is shrill due to high pitch. Frequency of voice of ladies and children is higher than that of men. Therefore, their voice is shrill. If the frequency is high, then pitch will be high. Frequency is low, then pitch will be low. Quality. Quality is that characteristics when we can recognize different sounds having same loudness, having same pitch, but we can recognize their voice. For example, some ladies are talking in the room. Their loudness is same. You are standing at the same distance. Their voice is shrill, pitch is same. But you can recognize which sound is, which lady was talking and which they are discussing. Why? Their pitch is same, their loudness is same, but we can recognize. If there are some children who are talking in the room, their voice is shrill, their loudness is same, but we can recognize which children is talking, which. This characteristics is called quality of sound. Since every children, every lady, every man has different waveform. Voice, every sound has different waveform due to which we can distinguish. This is called quality. Characteristics of sound by which we can distinguish between two sounds of same loudness and pitch is called quality. Musical instruments. These are musical instruments, and from these musical instruments, sounds of same loudness, same pitch, we can recognize. This is the first musical instrument, this is the second, and this is the third musical instrument. When all these musical instruments are playing in a room, without seeing them, we can recognize their sound. Which sound is from harmonium, which sound is from other instruments. While standing outside the room, we can distinguish between notes of piano being played inside the room. This is due to the difference in quality of these sounds, and this characteristics is called quality of sound. Waveform. Reason is this: every instrument has different waveform. This instrument has different waveform. Violin. This is piano. It has different waveform. Although their sound is shrill or their sound is musical, but their waveforms are different. Their loudness is same. Their pitch is same, but waveform is different, due to which we can recognize these sounds without seeing them. Intensity. Intensity is the energy passing per second through a unit area that is held to the direction of propagation of sound. When a person is talking, sound energy is emitting, and this sound energy which is passing in unit area in 1 second, that is called intensity. So energy which is reaching your ear due to my talk, this is called intensity. Intensity does not depend upon condition of the ear. Unit of intensity is watt per meter square. Example, this is the area, low intensity, less energy is flowing in unit area, and this is high intensity, more energy is flowing in unit